Everybody, it's Friday. It's 2:47. I realize my computer is about to die. I'm going to push pause and go get my charger. Okay, so much better. Let's see. Yeah, it's 2:48-ish Mountain Daylight Time in Denver. The weather's amazing. I've been inside most of the day, but I really need to get outside. As soon as I finish this post to you all to wrap up the week. You should see on your screen the syllabus page for our week. And let's see, again, today's Friday. You have the WebAssign 2 module due. I'm also about to send an announcement that you should read and engage with, talking to you about recent grades and how um, to work through those, review those, look at solutions, reach out with questions, that sort of thing. If anything, just know that in an online class or any class, once you get your grade, don't just don't just move on. Like take an opportunity to look at solutions for your worksheet, look at the discussion post, reach out to me with any questions, and don't feel afraid to do that. Your grades are an open conversation with me all the time. So please reach out. Please ask questions. Please question why you got the grade you did. It's totally possible there's a mistake in the grading, and um, and not out of an argumentative way am I telling you to reach out, but in a way of self-advocating. I want this class to be a place where you can learn to do that with a teacher, a professor. Then over the weekend, you do not have anything due, but worksheet 2 is due on Monday at the end of the day. I'll have my office hours Monday morning at 8 a.m. If you click the homepage, then you can find those. Homepage here at the bottom, office hours 8 a.m. to 9 a.m. You could click this Zoom link or this one. Both of them are the same link and they take you to the office hours. Then back to syllabus. If you do have questions over the weekend for worksheet 2, please feel free to reach out. Quiz 1 is coming up. You could click on this assignment to start to read quiz 1 details, but I'll address that more on Monday. Okay, the rest of the video, I'm going to do a quick problem on existence uniqueness theorem and maybe something else, but I think that's it. All right, you all take care and stay tuned. Okay,
Okay,
back
back
at
at
the video here. Let's
let's
try
try
this out.
out.
There might be
Might be
some
some
echo. If
echo. If
there
there
is,
is,
I'll
I'll
fix that
fix that
another
another.
time.
Uh,
You all
you all
been
been
looking
looking
at
at
first
first
order
order
differential
differential
equations.
equations.
You've been
Wondering
wondering if a solution exists for a first order differential equation, and if it does exist, is it
is
unique?
it
And to do
unique?
that, we've
To
used
do
the
that, we've
existence
used the
uniqueness
existence.
theorem. So this theorem applies to an initial value problem, and I, V, P, and two things have to exist for an initial value problem or to define an initial value problem. First thing is the differential equation, the derivative on the left, the real valued function on the right. Here, independent variables t, dependence y. You know the dependent variable because it's the variable of which you're taking derivatives. Here, you're looking for the derivative of y with respect to t. Then you also have an initial condition. So the ordinary differential equation along with an initial condition, this gives you an initial value problem. Then let's see, how do you use that to decide if you have a unique solution um, through a point? So there are two conditions that need to be met. The first is that the differential equation, the right-hand side, has to be continuous at the given point, and the partial derivative of the right-hand side with respect to y also has to be continuous at the given point. So for example, let's say you have y prime is t cosine y. This t cosine y, that's your f of t y. Does it have a unique solution through the initial condition y of 1 is 5? That's when t is 1 and y is equal to 5. Use the initial existence uniqueness theorem. So first condition, Look at the right-hand side, t cosine y. Both t and y are continuous for all values, including -1 and including 5 for y. Then if you look at the partial derivative of t cosine y with respect to y, t is a constant, so this is -t sine y. This is also still continuous for all t, all y. So if we were looking at a plane of values where we're guaranteed unique solutions. If we had a plane and this is t and this is y, we just decided that all t, so all negative t values, all positive t values, and all positive and negative y values, for all of those points, we're guaranteed unique solutions. So the 0.15 is, here's, whoops, let me go. There we go. There's the 0.1. Here's 5. So the 0.15, it's in our region where we are guaranteed unique solutions. And so, sure, there is a unique solution through that point. If we looked at another problem, does the derivative of y with respect to t equals t root y have a unique solution at the point 0, 0 when t is 0 and y is 0? First condition, look at the right-hand side, t root y. There are two, I guess the quick way to decide is, are we guaranteed a unique solution at this point, is to plug in t is 0 and plug in y is 0 and see if it's defined. If you did that, then we'd have, let me say, f of t y evaluated at the point 0, 0 would be 0 root 0. This is 0. This is okay. This is defined. If we look at our second condition, the partial derivative with respect to y of the right-hand side, t root y, this would be t over 2 root y. And again, you're evaluating at 0, 0, or wondering if it's defined at 0, 0. Here we'd have 0 over 2 root 0. This is undefined because we have a 0 in the denominator, since 0 in denominator. So this first condition passes, the second condition fails. So we are not guaranteed a unique solution through that point for that differential equation. All that means is we're not guaranteed one. There still could be one. We're just not guaranteed that there is going to be one. And that's a subtle difference, or a subtle, I don't know, thing to notice in this theorem, is if the theorem fails, this theorem is failing. It is not valid for this problem, this question. Is there a unique solution to that differential equation through the point? Theorem fails. We're not guaranteed one, but there might be one. If the theorem fails, it doesn't tell us that there isn't one. So, for example, and let's do this just to show you. So we looked at condition 1 and condition 2 with respect to the particular point. If we drew a plane of points where we're guaranteed unique solutions, so t root y, we're guaranteed for all t. So all t, let's do that, all t values. Then only when y is 0 or bigger. So if we look at when y is 0 or bigger, let's use a purple. So y is 0 is this line, and then bigger would be up here. So anything on the horizontal or above, any points in that rectangular region, we would be guaranteed a unique solution. But if we continue with condition 2, condition 2 restricts our domain. Condition 2, once we have t up here, t could be any value, but now the y is in the denominator. It can no longer be 0. So our domain for t is still the same, but y now has to be strictly greater than 0. Strictly greater than 0. There we go. So now come back to, let's see, come back to y being 0 axis and dash it. So to exclude it, that would tell us if we're looking at the point 0, 0, point 0, 0 is right here. 0, 0, we know y can't be 0. Therefore, we're not guaranteed a unique solution through that point. However, there is a solution through that point, and it's the solution y is equal to 0. But notice even though we're not through 0, 0, there is still a solution through 0, 0. It's the constant solution. Y is 0, or y of t is 0, the horizontal line. And you could check that. What was our equation? It was dy dt equals t root y. So dy dt equals t root y. To verify that y equals 0 is the solution, look at the left-hand side. The left-hand side would be the derivative of 0, and that's 0. The right-hand side would be t root y. So this is t root, and y is 0. Let me do this. So t root y, evaluate when y is 0, the solution y equals 0. This would be t root 0, and we get 0. And hey, look, the left and right-hand side are the same. So y equals 0 is a solution. I also think there might be another solution. Let me think a minute here. Let me pause. I'll come right back. Okay, yes, there is also another solution, and that's y of t is equal to t raised to the power 4, t raised to the power 4 over 16 through the point 0, 0. I'll let you, if you want, confirm that that is a solution. You, again, need to take the derivative of it and also plug it in on the right-hand side. So here our theorem failed. We were not guaranteed a unique solution. And when that fails, it just means it's inconclusive. We might have no solution through the point. We might have a unique solution through the point. We might have multiple solutions through the point. It just depends. So hopefully that's helpful. If you have any questions, please reach out. Also, if as you're watching videos, if here, let me pause for a second. Yeah. So I was saying, as you are watching videos through content, maybe you're on module 2, you're looking over the content for 2122, you watch some video and you're just left with a question or whatever. If the class were in person, hopefully you would raise your hand and your teacher would help you right then and there. We got to replace that somehow in this class. And so if you're watching a video and you have a question, or you want me to make another video or speak to that a little more, please pause your video, take down notes on what video it is, what time it is, screenshot it, something, and send me a message so I can address your question. Last thing before we go, we have a Discord server now. Its link is here. If you're not familiar with Discord, which I'm not familiar with Discord, but I can do it barely. Has been a great way to connect with people, students, teacher, in a real-time live way. So if you want help with homework, kind of meet online with the rest of the class, join that Discord server. Also, if you want access to any of my differential equation notes from when I teach in person, I created my OneDrive link here. So if you click this, it'll take you to a shared OneDrive folder for anybody at Minds with this link. And it's all my DiffyQ stuff. So specifically in class notes, if you selected, say, spring 23, that was my most recent class in person, then here are all the notes from when I would teach that class. If you want to look through them, if that's helpful to you. Okay, I think that's it. I know this video is longer, but hey, on YouTube, you can watch at double the speed. Maybe that helps. All right, y'all take care. Reach out if you need to. Have a good weekend.